Welcome friends to this series of Learning Google Cloud Platform. In the last lesson we learnt about load balancer. Now, in this lecture we will create a HTTP load balancer in front of the managed instance group that we created earlier. Are you excited to have this experienced? I am sure you will be delighted to have this learning. If you have not yet subscribed to this channel, please do it now. This will help you to watch when new videos will be available. Also please hit the notification button so that you can get notified too. So, let's get started.
So friends, this is our Google Cloud Web Console, and this is where we have created this Apache server managed instance group in earlier lecture. So if you haven't watched those videos, maybe you can just go back and check those videos and then come back here. All the links are provided in the description below. So what we have created, we created this MIG, and we did some release management as well. Right now, the second version of our instance template being served by these VMs. And you can remember that we had actually having one running instance and one suspended and stopped instance in this MIG. And we created these VMs as a spot VM. So maybe n number of times these VMs were taken back, but this MIG successfully created a new one and kept the pool as required, as a stopped one and a suspended one. So this is how our MIG is running absolutely fine without having any downtime. And what we are going to do in this particular video, we are going to have a load balancer in front of this MIG so that our web application can distribute the load between different VM instances. So for example, if we are having 3 instances with us, so if we are having any web requests to get served from these instances, maybe we can distribute the loads between these 3 instances or so. So this is what we are going to do. So just note that our MIG is zonal MIG, and all these VMs, whatever the VMs are there, or in future, if there is any VMs to be created, those will be created in US Central 1C zone only. So our load balancer will basically load balance all the VMs within the zone. Maybe we could able to create a regional MIG where we can have all the VMs will be created in US Central 1, but maybe if one VM can be created in Central 1A, some VMs can be created on B zone, or maybe some VMs can be created on D zone, or so on. So in that way, we could able to make our application highly available if the entire zone got crashed or damaged, or there is some disaster happened in this particular zone, US Central 1C, so that at least our application can be served on US Central 1B or A or other zones. So in that case, we could ensure the high availability through this load balancing procedure. So it's not only distributing the traffic between these different VMs in the same zone or same region, as well as it will provide the high availability in case of disaster of a single zone. So there are multiple use cases of a load balancer, but here what we are going to do, we are going to check how the traffic can be distributed if we put a load balancer in front of this MIG. Okay, so first what we are going to do, we are going to edit this MIG, and maybe we can keep 2 running instances all the time so that we can distribute the load between these 2 instances, and we can drop our standby pool. So maybe we can make it 0 and 0 because we don't need any standby pool, for example, and we can keep everything same, or maybe we can keep this as 3 or the maximum number of instances. So what it will do, it will create two instances hot running all the time. And if any, any kind of a request comes to these web servers, so it will distribute the load between two instances. So if we put a load balancer in front of this MIG, it can distribute between these two instances. So if we save it, so what it will do, it will just drop the standby pool and create two other VM instances. So um, let it do this stuff. So once it is done, I will come back. Till then, I'm just pausing my. Okay, so the update is done, but what it is going to do right now, it is actually scaling these instances down to two. So right now it is scaling down to two. So it's done. So if you see, we are having right now one instance up and running, and the other one is being terminated. So right now, if we go ahead and check these uh, web application, we can see that our web application is rubbed and it is saying. So another VM instance is basically being created right now. So we need to wait for some time, and yeah, it's done. So right now we are having two instances in our MIG. Both are spot instances, and both are actually serving um, uh, web application. So that's fine. So we are ready to put a load balancer in front of this MIG. So in order to create a load balancer, we can search the load balancer in the search box, or we can um, go from here as well. Okay. So if we click this hamburger menu and if we go to this network section, we can see the load balancer is one of the options. So if we go to this load balancing section in the network services, we can find there is no load balancer being created. So if you click this create load balancer, we can see there are three kinds of load balancer we can find. The interested one is application load balancer, because we are going to serve one web application having this HTTP or HTTPS port. So we can go for this application load balancer. But there are other kinds of load balancer like network load balancer for layer 4 load balancing. If you are having some kind of application that is being solved from non-HTTP or non-HTTPS ports, and you are really want to get the heartbeat from your application client end. So in that case, you can go for this network load balancer. But if you are really want to make some kind of video streaming application or something like that, and you don't need to bother about how much seek has been done for your user, so you can go for these UDP load balancer or network load balancer. So in our case, we should go for this HTTP load balancer, because we are having the MIG that is being served from 80 ports. So start configuring these load balancers. So what it is saying that it does it want to have internet phase or intranet phase. So if you are basically serving a web application, normally we put it in internet, so that any user can go and check for this IP that is being provided by HTTP load balancer, and from there it can go to the backend managed instances group. So we are going to use this one, but if you really want to keep the entire application within your network and with your private network, you can go for these only between these VMs or services. Okay. So now it is asking for whether it can be global or regional. So we can go for regional, because all our application or VM instances are being served from US Central 1 zone, and we can go for region in that case. But if you are having MIGs in different regions deployed, and you want to keep a load balancer in front of them, and you can have different backends for that load balancer. You can go for this global load balancer. And and the good point in this global load balancer is that if it can do some kind of location sensation, for example, if we are having a user from US region, the global load balancer will serve the US users closest to his VM that is deployed in US region. But if your user is in Asia, and if you are having a MIG hosted in Tokyo, so that the Asia users can be served from this Tokyo MIG. Okay, so in that case, global load balancer will be really helpful. In our case, we can go for this regional one because all our VMs are in US Central 1, as we saw, and we have created. Okay, so first and foremost thing to give some name, so maybe we can say my load balancer, and we have to provide some kind of front-end configuration. So in that case, I'm not interested to give some name, so we can just keep it blank and see. I mean, we are interested for HTTP port because our application is being served from HTTP 1. So for network, I am having only default network, and we are having this proxy only subnet enabled, and we have reserved this one for uh, this load balancer, this private IP address. Okay, so I'm just going to keep done, and then let me go to the backend. And for the backend, I need to create a backend service. So for this backend service, what it will do, I mean, it's a backend service that is being served by the instance group. So here we need to provide some kind of name. Maybe we can say my backend. Okay. And if you scroll down below, you can see that what kind of backend it should be. So I have only one MIG. I can click this one, and our port is 80. So that's absolutely fine. Here we can balance the load either by utilization or rate. So if you see, determines how the load balancer distribute request among backend instance groups or the MEGs. For HTTP supported load balancing, that is what we are doing right now. We can go for the utilization, but we can use the rate for the instance group for network. Okay, so when a backend has reached a configured maximum utilization or rate, the load balancer will direct the new request to other backends that have not reached their configured maximum. Okay, so if this backend is being utilized for 80% of CPU, then it will go for the next one. Okay, so we are only having one backend. Maybe in the upcoming video, we can see, I mean, we can create multiple backends for a load balancer, so that how it can be served between these load balancers, between these MIGs. Okay, so backends are ready. Now we have to provide a health check. So maybe we can reuse our health check that we have created for the MIG. Okay, so that it will continuously check whether these are really healthy or not. Okay, so in advanced configuration, we have a couple of things like, session affinity, and that modifies the traffic distribution. It can be client ID, it can be generated cookies. So if it is client IP, then connections from the same source and the destination IP address will be go to the same instance. So if this particular client IP is the affinity is selected, then whenever a same machine will be used to access the web application, then it will be served to the same backend for that particular machine. Okay, from where the client is sending the request to provide the web application details. Okay, so all these things we can do, and the location load balancing policy is round robin. We can have different kind of things like a last queue, last request, rehash, random, original discussion. We are fine with the round robin so that it can be solved. We can see that from once it is solved by 1 p.m., then the next request will be solved for the other one. Okay. Okay. So already we are having this backend ready. If we want to provide another backend, we can provide that backend as well. So right now I'm okay and I'm going to click this create button. So let the load balancer be ready, and till then I'm just going to forward it. Okay, excellent. So our load balancer is ready. So if we go and check the load balancer, it will provide me an IP, and we can use this IP to see mm, our web application. So we can see that two of two instances are held in our backend, and we can just copy this one. And what we will do, we will basically um, go our Cloud Shell, and we can continuously check if we can see both of these backend MIG VM instances are capable to solve the request. What we will do, we will call this IP address, and we can see so internal IP address is getting changed. So sometimes 39 and sometimes 50 are being used to solve these web application. Okay, so this is how this load balancer works. Okay, so right now we are not using the MIG's VM instances IP address. We are using these load balancers, external IP address, Anycast IP address, and once we use that one, we can see instances. So if we go ahead and check in the web browser as well, we can see this load balancer will sometimes give the IP address of 50, and sometimes will give the IP address of 39, because it is the traffic is being routed to both of these instances in packet. Okay.
Thank you friends for watching this video. We from the Learning Light team congratulate you to complete this learning. In this lecture, we saw how a load balancer can be created in front of a managed instance group. However, all the instances are from same zone US Central 1. In the next lecture, we will learn how to use load balancer to distribute the load between different regions like US and Delhi. Wish you all the best and good luck. Before leaving here, please do not forget to like this video and subscribe to this channel. We worked a lot to present you with such a thing. So, please encourage us by putting your comments in the comment section. If you have any doubt, please leave your concerns and we will reply with our best efforts. Have a nice day and see you in the next lecture.